Can AI really beat the biggest models with less training? And can it solve problems in ways we've never imagined? A new AI model trained on just 14% of its competitors' data is outpacing the biggest players. Another model is thinking in hidden loops, changing how AI solves problems. Smarter design is now proving to be more powerful than just using massive amounts of data. Let's talk about OpenThinker-32B, an open-source AI model that's making waves. It was built by the OpenThoughts team and fine-tuned from Alibaba's Qwen 2.5 TOB Instruct. This model has 32.8 billion parameters and a 16,000 token memory, making it powerful. What makes its training special? It learned from the OpenThoughts 114K dataset, which includes 114,000 carefully selected examples. Each example comes with detailed instructions, correct answers, and coding test cases. To ensure accuracy, the team used a special system to check code solutions, and an AI-based judge verified math proofs. This approach helps OpenThinker-32B solve complex problems with high accuracy and smart reasoning. The training process for OpenThinker-32B was quite interesting. The team trained it 3 times over the data using the Llama Factory framework. They set the learning rate to 1e5 and used a cosine learning rate scheduler, a smart way to slowly adjust how fast the model learns. For computing power, they used AWS SageMaker with 4 nodes, each running 8 H100 GPUs. Even with this setup, training was finished in just 90 hours. They also tested an unverified dataset with 137,000 samples on Italy's Leonardo supercomputer. It took 30 hours and 11,520 A100 GPU hours to process. While these unverified results were still good, the fully verified model performed the best. When it comes to benchmark performance, OpenThinker-32B holds its own against some of the biggest names in AI. Let's break it down. One of OpenThinker-32B's strongest areas is its mathematical reasoning. It scored 90.6% on the Math 500 benchmark, a dataset designed to test how well AI models can handle complex mathematical problems. This is an exceptionally high score, surpassing even some of the most powerful proprietary models from well-funded AI labs. Additionally, for general problem solving, OpenThinker-32B scored 61.6 on the GPQA Diamond benchmark. This benchmark evaluates an AI model's ability to reason through various real-world and abstract problems, making it a crucial test for logical and analytical AI capabilities. When it comes to coding tasks, OpenThinker-32B also shows strong potential. It scored 68.9 on the LCBV2 benchmark, which assesses AI models on code generation and problem solving. However, in this area, OpenThinker falls slightly behind a major competitor, DeepSeek's model, which scored 71.2. This suggests that while OpenThinker is highly capable of coding, there is still room for improvement when compared to top-tier models. Despite not taking the top spot in coding, OpenThinker-32B has one key advantage: it's fully open source. This means that developers around the world can access, modify, and fine-tune the model to make it even better. Unlike closed-source models, where improvements are restricted to in-house teams, OpenThinker allows the broader AI community to enhance its capabilities. This means that while DeepSeek may currently lead in coding, OpenThinker has the potential to catch up and even surpass it as the community refines and optimizes its performance. Since AI models improve significantly through fine-tuning on domain-specific data, OpenThinker's open-source nature gives it a long-term edge. The open-source nature of OpenThinker-32B is a game-changer. Big companies like OpenAI and Anthropic keep their training data and methods secret, making it hard for smaller research teams or independent developers to learn from or improve their models. But with OpenThinker-32B, everything is fully accessible. Anyone can study the code, analyze the training data, and even replicate the process. What makes it even more impressive? Despite using only 114,000 training examples, it performs as well as, or even better than, some high-profile closed models. Compare that to DeepSeek, which trained on 800,000 examples, 7 times more data. Yet, OpenThinker-32B holds its own, proving that smart design beats brute force. Now, let's compare OpenThinker-32B to DeepSeek R1. Both are open source models, but there's a key difference. DeepSeek R1's training data isn't public, while OpenThinker-32B is fully transparent. In terms of performance, OpenThinker-32B slightly outperforms DeepSeek R1 on reasoning tasks. It scored 90.6% on Math 500 compared to DeepSeek's 89.4%, and won on GPQA Diamond with 61.6 versus 57.6. However, DeepSeek has an edge in coding and some advanced math tests like AIM benchmarks. Despite using way less data, OpenThinker keeps up with DeepSeek, proving how efficient its training is. The team is already planning future updates, possibly expanding the context window or tweaking its structure. And for those with limited hardware, there's a lighter 7B parameter version, perfect for experimenting without needing a high-end GPU. Another exciting model making waves is Hugan 3.5 BBL, designed for high-performance reasoning with even more parameters. Developed by an international team, it includes experts from Ellis Institute, Max Planck Institute, Tübingen AI Center, University of Maryland, and Lawrence Livermore National Laboratory. With such a strong lineup, it's clear that serious research has gone into this model. One of Hugan 3.5B's standout features is latent reasoning. Unlike traditional chain-of-thought methods, where AI shows every step of its thinking, Hugan processes information internally and refines its understanding before generating a final answer. This makes it more efficient, especially for complex or large queries, since it doesn't waste space storing unnecessary reasoning steps. This means better performance without filling up the context window too quickly, a huge advantage in AI reasoning. At the core of Hugan 3.5 is a powerful feature called recurrent depth, which sets it apart from traditional AI models. Instead of processing input once and generating an output, it loops through its internal state multiple times, refining its understanding before producing a final response. Think of it like solving a tough math problem. Instead of writing out every step, a person might scribble on the back of an envelope, checking and refining their work quietly before arriving at an answer. Hugan 3.5B does the same internally, allowing it to handle complex proofs, multi-step code generation, and deep reasoning tasks more efficiently. One of its biggest advantages is memory efficiency. Traditional chain-of-thought methods require generating many intermediate reasoning tokens, which fills up the context window quickly. Hugan sidesteps this by iteratively improving its internal state, almost like updating a mental notepad rather than expanding the output. Underneath, Hugan 3.5B is still a transformer model, but with an innovative twist, a looped processing unit. This allows it to run extra computations during inference, adding more logical depth without increasing its static parameter count. The result? More power for complex tasks, but with the flexibility to adjust computation levels based on difficulty. For easy problems, it loops less, solving them quickly. For harder problems, it loops more, enabling deeper analysis without needing a massive model size. This balance between efficiency and intelligence makes Hugan 3.5B a breakthrough in AI reasoning, pushing the limits of what's possible in step-by-step problem solving. Now, let's take a closer look at how Hugan 3.5, the model learned from an enormous dataset, 800 billion tokens, sourced from multiple domains, including general text, programming languages, and mathematical reasoning tasks. This diverse training approach ensures that Hugan can handle complex coding problems, advanced math proofs, and structured reasoning challenges with high accuracy. What's even more fascinating is how the training method works alongside its unique recurrent depth architecture. Instead of simply memorizing answers or providing one-shot responses, Hugan was specifically trained to process information in multiple stages, much like human reasoning. This means it doesn't just retrieve stored knowledge, it analyzes, refines, and builds logical conclusions step by step. This ability makes it especially effective for multi-step problems, coding solutions, and abstract reasoning tasks. After training, Hugan 3.5 was tested on some of the toughest AI benchmarks, It performed exceptionally well on ARC, AI2 Reasoning Challenge, a dataset designed to evaluate AI's ability to answer standardized test-style questions, requiring logical thinking rather than simple recall. Additionally, it excelled on GSM-8K, a dataset focused on challenging grade school math problems that push AI models to follow detailed reasoning paths. What's truly remarkable is that despite having only 3.5 billion parameters, Hugan outperformed much larger models like Pythia, 6.9 billion, and Pythia 12 billion. This proves that efficient architecture and better reasoning strategies can surpass raw model size, making Hugan a breakthrough in AI problem solving. That's all for now. Thanks for tuning in, and see you in the next one.